So hello students, I am here with the possible solution from the question 2 to question 10 for the Black Scholes model. Since I have been posted you the one complete problem discussion for the problem 1, so rest are few are the similar and with small changes, right? What I expect from you students is to solve this problem and upload so that it is a learning. Since I keep solving and posting, it may not be in a two-way learning. I feel like, so let's take a chance from your end and ask you to solve this problem. So what I'll be giving to you is, since I already posted the list of students and the question number which they are supposed to solve in the WhatsApp group, right? So if you just look at the question 2 is quite replica with respect to the question 1, right? It's a simple underlying asset with no income history. S naught is given, a K is given, risk-free rate is given, standard deviation is given, time to expiry, and option type is only call European you're supposed to calculate, right? So question 2 and question 1 is quite similar. Get me the solution. Question 3, if you just look at, right, what is that they have been given to you is, it is also quite similar to 1 and 2, but thing that we need to make a note here is they have given the variance of the stock return as 0.49 percentage, right? So as for the given data for the Black Scholes model, we require a standard deviation. So I had to convert the variance to the standard deviation, right? The variance is given as 0.49. So to convert the variance to the standard deviation, I need to take the square root of the variance. So the square root of variance is root of 0.49 comes out to be 0.7. So here the standard deviation is 0.7. So rest, again the underlying asset has no income history. Apply the case 1 formula and get me the solution. This is about question 3. Coming to question 4 here, using the following data, calculate the value of call and put option on the stock. So what is given here is the spot price is given, exercise price is given, risk-free rate is given, standard deviation is given as 0.42, and time to expire is 45 days, continuous dividend rate on the index, right? So here they have been given as a dividend yield to you. So apply the case 3 formula here, that is 1.8%. Okay, so I'll be using the case 3 formula here, that is call option price is equals to S naught into exponential to the power of minus delta into t, right? So when I say minus delta value is 0.018, 1.8% is given. I will be converting that into decimal. It will become 0.018, then multiplied by t, that is 45 divided by 360 into n of d1, that is normal distribution value that I need to calculate, minus exercise price e into exponential to the power of minus rt. R is given as 8% into t, that is 45 divided by 360 in n of d2, right? So I need to calculate n of d1 and n of d2, normal distribution value of d1 and d2, right? Similarly, if I want to calculate n of d1 and n of d2, I need to calculate d1. d1, the formula is log value of s naught by k plus open the bracket r minus delta. So the r value here is risk-free rate 0.08 minus delta value is 0.018, close the bracket, plus standard deviation is 0.42 square divided by 2. Simplify these two values and multiply that with 45 by 360. Okay, and further you can calculate d2 and calculate n of d1 and n of d2 and n of minus d1 and n of d2, and substitute that in the main formula of option pricing for call and the put. You will be getting the option price. Fine. So this is about question 4. So question 5. So question 5 is about current price of the index is stock is given to you as 85 and excess price is given as 85, right? Both the values are 85 and 85. Sometimes even what they give is they don't give you the spot price and the strike price. They will say as simple at the money, right? So both stock and the strike is at the money option. When they say at the money, you need to take any value you take, it would be equal to 1. Fine. So here it is given as 85 and 85, it will be equal to 1, or sometimes they will give it as a at the money option. Fine. Then we need to understand that the spot price and the excess price are the same. Fine. So then time is given as 160 days, Treasury bill is given as 5.18 percentage. Treasury bill is nothing but risk-free rate of return here. Then standard deviation of annual return is given as 44 percentage. So it is given standard deviation in the 44 percentage. We need to convert that into the decimal, that is 0.44. Okay, so rest is the same here. Rest all other things are similar to that of case 1. Fine. Only thing is you need to be careful while taking the standard deviation, that is they are given in the percentage, we need to convert that into the decimal. Question 6, let's look at here. Question 6 is following data is given to you: current price, exercise price, time to expiry, standard deviation, continuous compounding, risk-free rate, and the dividend is being given in the form of cash of rupees 12 in 27 days, right? So this is with respect to case 2, where dividend is given in the form of cash. So what I need to do here is I will be using the formula of case 2, that is C, that is call price is equals to S naught star into ND1 minus K into e to the power of minus RT into ND2. Right? So if you want to get the value of S naught star in the formula or the final formula or in between, wherever we come across S naught, I need to take that as a S naught star. Right? What is this S naught star? S naught star is nothing but S naught, that is the spot price minus present value of the dividend. So S naught is given as 486 minus, so dividend is given as 12 into e to the power of minus 0.09 into 22 by 360, that is the dividend is expected in 27 days. So hence I take the present value of the dividend and subtract it from the spot price. So I will be getting the S naught value. S naught value is somewhere 474.12. Rest is all the similar, D1, D2, ND1, ND2, right? You need to calculate both call and the put option and get me the solution. Fine. Question number 7. Question number 7 here is, again we are given the data like spot price, strike price, risk-free rate, time, and standard deviation is given to you as 20%. As we know that it is given 20%, we need to take as a 0.20. The other important thing that I need to make a note here is dividend yield is given as 0.2%, that is 0.2% and 0.3% are expected in first and second month respectively, right? So what does it mean? We know that dividend yield should be expressed per annum. Okay, so standard deviation is expressed for per annum and dividend yield should always be expressed for the per annum basis. Fine. So since here the dividend yield is not given for per annum, I need to convert the dividend yield to per annum basis. So what is that I need to do here is, first I need to understand first dividend is expected in first month, second dividend is given for second month. So first month plus second month, it is equal to 2 months, not the 3 months. That is first dividend is 0.2 is expected in first month. Let's assume it is January. The second dividend, which is expected as 0.3, is expected in the second month. Let's assume it is February. So January plus February, it will be equal to 2 months. Okay, just do not get confused. First and second is equal to 3 months. First and second month is equal to 2 months. It is okay. For 2 months, the dividend yield is 0.5. That is 0.2 plus 0.3 is 0.5. If for the 2 months it is 0.5, then for 1 year, what is the dividend yield? For 1 year, the dividend yield can be calculated here as it is shown, 12 into 0.5 divided by 2. I'll be getting the dividend yield per annum as 3%. So once I get the 3%, I will be applying the case 3 method formula and get me the solution. Okay. Question 8. Question 8 is about spot price is given, strike price is given, risk rate is given, time is also given, standard deviation is also given, right? So we have a 2 questions, sub question A and sub question B, right? Case 1 and case 2. Let's assume that as a case 1 and case 2. Case 1 is very simple, where you calculate the value of the call option, that is case 1 with no income of dividend, right? So case 2, what is that we need to look at is, we need to take the changes with respect to the standard deviation, right? In the first case, the standard deviation that we are taking is 0.4 and calculating what is a call price. In second case, other values like spot price, strike price, risk-free rate and time is the same. Only thing that we need to take here is the standard deviation as a 0.50, and we need to show what is a change in the option price when the standard deviation change from 0.4 to 0.5, that is for 1 or else a 0.10, right? So for 0.10% change in the standard deviation, what would be the possible change in the option price is what the question 8 is about, right? So both we apply the case 1 formula, that is underlying asset not paying any dividend. Fine. Then question number 9. So question number 9 is, again we are calculating about the index. Index has a 3 companies and its information is been given. So this methodology we have been familiar when we have been solved in the model 2 of future contracts, question number 7. If you just look at, right, I posted you separately the methodology, how to proceed, then also we have solved few of the problems, so you are familiar with this. So I had to apply the 4 stages: stage 1, stage 2, stage 3 and stage 4, and calculate what is the dividend, that is what is the present value of the dividend. So once I calculate the present value of the dividend, then I need to apply the case 2 formula of the option pricing, that is S naught star ND1 minus K into e to the power of minus RT ND2. So S naught star is S naught minus present value of the dividend. So what I have been calculated in the stage 4, the present value of the dividend, that has to be subtracted from the S naught, that is the spot price. I'll be getting S naught star. So once I get the S naught star, keep substituting this S naught star wherever we come across S naught into the formula and get me the solution. Coming to question 10, so I'll be solving only the part B here. Part A and part C that you are supposed to calculate. So what is that it is given is spot price is given, strike price is given, right? Time is given, standard deviation is given, and risk-free rate has been given. So first question, what is that it asking you to calculate? What is the Black-Scholes price for a call? It is very simple formula. Apply the case 1 and get me the answer. So I just gave you the answer here, possible answer. You need to solve me in detail and show me the answer. Coming to the question B, use put call parity to price in a European put. So here I had not been discussed to you about put call parity. So coming in the next classes, I'll be talking to you about like put call parity. Just to understand you, it is one of the method to calculate the value of the option, right? So it is very useful to calculate the price of an option of any one type if the other type is already known. Suppose I already know the call option price, I can calculate easily the what should be the put option price. And also the put call parity is being used for understanding the arbitrage. And the standard formula for the put call parity here is C stands for the call price or the call premium, what we have been calculated or it is being given, plus K is the strike price into exponential to the power of R into T is equal to P. P stands for put price, right? C stands for call price and P stands for put price, that are put premium, plus S naught stands for spot price. By substituting the prices, so C that I have been calculated in my sub question A, that is I got it as 13, plus exercise price is given as 150 into exponential to the power of minus 0.06 into 3 divided by 12 is equal to P, that is put price. So since I have not calculated the put price by using Black-Scholes model in the sub question 1, so by using put call parity, I will be calculating the price of a put option, right? P plus spot price is given in the question, that is 155. By simplifying this, I will be getting the price of a put option, that is equal to 5.77. It is an alternative method to calculate the price of an option, either call or a put. Fine. So this is one about put call parity. Third sub question what is been given is, if the share price declines to 153, that is nothing but spot price, right? The spot price is given as 155 in the case 1. In the case 3, if we take spot price as 153, then what would be the call price, right? So I have been posted to you about the conceptual understanding of the different variables. All these variables, the 5 variables of spot price, strike price, standard deviation, time to expiry, and the risk-free rate are responsible for the change of call option price into the market, right? So these are the factors which are acting for the changing in the prices of the option to increase or decrease, increase the demand or the increase in the supply, right? So first thing in this case, what is that we are trying to look at is changes in the spot price. What would be the change into the option price? Fine. So case 1 we are taking as a 155. In the case 3 we are taking as 153 and calculating what is the call option price, the change in the option price. Fine. This is about the input. I expect you all to solve and fulfill the expectations. If you have any query, please drop your query or call back to me for your clarification. Okay. Thank you. Have a good day.